Hello, everybody. I'm Alex. I'm here joined with Chaoyun from the DKI team, the Data Knowledge Intelligence team based in China. And he's going to be presenting on the AI Agent OS, what's known in the open source research paper, the UFO paper. So Chaoyun will present and I'll hand it off to him.
Thank you, Alex. So, hi, I'm Chaoyun from DKI team. So today I'm going to talk a bit about our recent source and work on how to use AI agents to revolutionize the user experience and their interaction with their personal computer or desktop. So here is our vision. So just think about how they use their computers to do their daily tasks. They need to learn how to use different app or software on their desktop, and also after the learning that you put a lot of effort to like clicking on these different UI control and type something on the keyboards, which we believe is kind of time consuming. So our vision is that why don't we replace all of this effort with agents? So if we have agents, they can accept the user requests in the natural language, in the natural language to understand that and just automatically complete their tasks on their laptop on the user's behalf. We think this is the future of the AI PC. So and this is quite valuable to both the end users and app developer. So for the end users, our agents will provide a new UI interface for to interact with their desktop with natural language. Since the agents will become the expert of the app, so the user do not need to learn how to use the app. So the agent will know how to use it, and you improve their efficiency of their task completion. So for the app developer side, I think our agents will provide an easy transformation of their existing app into the app agent in a very scalable way. So they don't need to put a lot of efforts on that. And also, we hopefully, after we culture these ecosystems, it will provide the app developer with with some monetizations avenues to improve the salaries or uh, so to illustrate our idea, I'm going to play one video. So in this video, we try to integrate our agents into the Windows systems, and we use the uh, Windows taskbar as an entry point to accept the user request, and then it completes the task on their desktop. So I'm going to play this video. This video just show how the UFO can accept like the user request in a high level and try to decompose this task into a different subtasks across the Outlook and the slides. So one of the good thing about this is that you can see the UFO can leverage the in-app copilots in the PowerPoint and use that as a toolbox to generate the slides. So which means that it can do more than the current copilots because it can use that as a tool. Okay, to achieve this, we designed the overall framework of the UFO. Here, you can see there are three main components of the framework. So so on the very bottom, there are different Windows applications, including the first parties like M365 and the third party. Um, so beyond on the top of it, we will have the app agents. So the app agent here is an expert users of a specific application. So one application will correspond to one app agent. Um, so to become an expert, each app agent will use lifelong learning to observe different knowledge from different resources, including the bin search, the help doc, to really understand how to use this app. And it can has diverse knowledge resources. And it also has a rich skill set of how to use this application, including the UI control information, include like the clicking and typing, and also you will try to leverage the code API that the provided by the application, and also you can use the native agents such as the copilots. So on the top of the app agents, we will have the host agents. So the host agent basically takes the managing role. So from between and it actually bridge the gap between the Windows users and the application. So for the users, you provide a channel for the user interaction. So basically, you will try to accept the user request in natural languages, and you will try to decompose the tasks into different subtasks and assign to different app agents. So for the app agents, you will try. So for the app agent, you try to manage their task completion, including how to assign different tasks to different app agents, and also schedule their tasks in different orders, and try to monitor whether this task are completion or not. And it actually serve as the kernel of the agent OS. Um, to empower these two agents, we will have the core of this framework is called the large action model, which is LAM. So the LAM actually is a variance of the large language models, but the difference that instead of outputting the natural language like the LM, it also outputs the action sequence. So it's a foundation model that was optimized for this task, for this action execution task, and also for the action planning, and it's much faster and hopefully it can serve at a local computer, so to reduce any privacy concern. So let's begin at the app agents. So the app agent, as I just mentioned, is is an executor of different subtasks assigned by the host agents. So you plan at the local application level. So and hopefully you become a expert user of individual application. So with this, the users will just don't need to learn how to use these apps, and the app agent will do this for the users. So the key feature of this app agents is that you can react with the large action model. So you try to observe the current state of the applications, and it generates results on how to complete the current request, and you translate this results into the action, and you will do this in a recursive way. So to enable the app agent to complete the different tasks, diverse tasks, you try to enhance its comprehension of this application with different external knowledges and demonstration library. So for the external knowledge source, we will have the offline app help documents. This is typically from the app provider on any online resources, and also we try to use the online bin search or copilots from the public to search the solution for completing a request just online. Yeah, and it's and except for this, we will have a demonstration library. So the demonstration means that either the users or the agent itself, you will generate some task completion trajectory. An agent will try to save this and retrieve this in the runtime to know how to complete this task. So for the demonstration library, we will have the one from the agent itself that it generates from its previous successful experience, and we will save that into this is long-term memory. And also we will have the human demonstration. So this means that the users can just demonstrate the task completion to teach the agents how to complete one task step by step, and we also save this into its memory. Also, another things we think is cool is that we are building a sandbox to allow the agent to self-explore on this sandbox on a specific application. So, and this will just generate a lot of a successful trajectory or a failed trajectory. We will extract this successful trajectory as the demonstration into this demonstration library. And to interact with this application, you have different tools, including the in-app copilots and also the native code API and also the UI control. So with these tools, the agent can control this application in different way, and and you can enhance this ability. So here I'm showing you the React workflow. So basically, in the observation side, the agents will observe the app's data, including the UI control, UI key here, and the app screenshot. Here I'm showing an example of a screenshot here. Basically, we use the tool of the UI automation that provided by the Microsoft. You will try to detect the available UI control on this application interface, and we will tag each control with this number. And the agent, after observing these numbers and this UI control screenshots, the agent will try to select one of them to apply an action, such as the clicking or typing something. Yeah. After you have this observation, you generate its source. So the source is basically the logical thinking on the current action and like what it should do and why it should do it. And also after you have this source, you will try to plan on the next step subtask completion to provide for the future step. Also, you will try to detect the sensitive actions that is potentially cannot be reversed, or it can be like harmful to the system, such as rebooting and deleting a file or something like that. After you have these thoughts, you try to translate these thoughts into the action sequence. This can include the call to the copilots in the application, or the call to the native API of the app, and also the actions through the UI control, such as clicking and typing. And now I'm gonna show you some skill that we try to enhance these app agents. The first thing I'm showing you is how it can leverage the external knowledge source. So here we are trying to inject different external knowledge into the application. So such as we will have all help documents, official help document of the application. So this will provide the reliable usage guidance. And so the way the agent uses it is through the IRG, which is the retrieval augmented generation. So after the agent receives a request, you try to search whether there's a help doc that match this request, and you will use this retrieve help doc as the external knowledges. But sometimes the help doc might be just out of date. In these cases, the app agent will try to search some solution from the online bin search or copilots, and this will just provide expanded and more up-to-date knowledge to to these app agents. So here I'm going to show you a demo on how the UFO can use the bin search to search the up-to-date results to complete a user request.
Welcome to the demonstration of UFO, our cutting-edge Windows UI-focused agent designed to streamline complex tasks effortlessly, freeing up your hands for more important endeavors. In today's showcase, we'll highlight how UFO, in collaboration with Bing Search, can swiftly remove all notes from a PowerPoint presentation with just a few simple steps. Imagine you have a presentation named UFO Testing with notes on every slide. The traditional approach might seem tedious, but with UFO, the process becomes remarkably straightforward. Let's initiate the request by instructing UFO, help me quickly remove all notes in the slides of UFO testing. Now watch how UFO intelligently streamlines this task without the need for manual, slide-by-slide intervention. To formulate an efficient plan, UFO initiates the process by querying Bing Search for the fastest way to remove all notes from a PowerPoint presentation. Then it reviews the first search results, distilling a comprehensive plan from both textual information and visual elements. Following the searched solution, UFO plans to employ the Remove All Presentation Notes function, a feature often overlooked by many PowerPoint users, and it is hidden in a secret place. It automates this process and begins by navigating to the A File tab to access the backstage view. Next, UFO seamlessly moves to the Info menu, where the desired function may be located. To inspect the document for notes, it clicks the Check for Issues button and selects Inspect Document. Once inspected, our black magic, the Remove All Presentation Notes option, is tucked away at the bottom of the menu. UFO, being aware of this, scrolls down, locates the function, and initiates the click. Given that deleting notes is a critical action, UFO ensures user confirmation. Once confirmed, all notes vanish with just one click. Let's verify whether all notes have indeed been deleted. Wow! UFO executes the task flawlessly, transforming a seemingly complex process into a simple yet specialized maneuver in collaboration with Bing Search. Isn't it impressive? Discover the convenience of working smarter, not harder, with our Windows UI agent UFO.
So the previous demo just showed the UFO how to search results online. To like complete a task that might be like a niche that both humans and agents that do not have these knowledges, and you can just search the up-to-date results to get the better solution. Okay, so the next enhancement to the app agent is that we somehow find a way to demonstrate some task completion trajectory to the app agent, so it can provide more like precise task completion. Especially for some third-party app that do not have the official help doc and do not have much searching results. So here the demonstration view from 3 different sources, including the this previous experience. So the agents might just have some successful task completion trajectory. We try to save that into demonstration library for the future usages, and also we build a tool that allow the human to demonstrate their own task to the agents and record their actions. Use the tools like clicking or typing, and after that we'll save this trajectory, and the agent will just try to mimic the user trajectory and actions. And also we are building a sandbox to allow the agent to self-explore on the software, so that it can generate a lot of like trajectory that can be usable for the future task completion. Here I'm showing you how to use the tool in the built-in Windows. That's called the use the tool in the Windows, and you can just record the user's actions. We pass this trajectory into a required format that allows the user to consume it.
This video will demonstrate how UFO learns from user demonstrations. Despite its advanced capabilities in interpreting and executing commands seamlessly, UFO, like any technology, may encounter difficulties in accurately understanding complex user requests. To address this challenge, UFO employs a sophisticated approach. It observes and analyzes user interactions to adapt and improve its performance over time. The user requested UFO to help them set a daily exercise notification. UFO accurately interpreted the request and created a task in Microsoft To Do. However, it seems to have encountered difficulty in establishing a recurring reminder, resulting in no further action. Microsoft Steps Recorder is a built-in Windows tool designed to capture a series of user behavior. The user employs Microsoft Steps Recorder to demonstrate the correct procedure for setting a daily study reminder, which is similar to the previous task failed by UFO. Providing detailed commentary could aid UFO in understanding the user's intention. Leveraging the recorded demonstration, the UFO assimilates the user's actions, formulating multiple proposed solutions. The user selects the most suitable option, which the UFO saves as a reference for similar tasks. After analyzing the demonstration of user's request, remind me to study every day. UFO effortlessly replicates the process for a similar task. Remind me to take exercise every day. As a result, UFO effectively creates the task and establishes a recurring reminder without any issues.
So this video just showed that after the user demonstrations, and then the agents can just complete the task for much better. And also it's a good way to like achieve the customization for the task completion, because different users might have their preference, and if they use this recorder to record their preference, then the agent just can mimic that for the future work. Okay, so here I'm showing you the exact skills that the app agent can interact with the application. Here we have the three kind of the skill. The first is the AI tools here, and this will include the copilots of the application, including the Windows copilots and the M365 copilots, and that all of them can be a toolbox that can use by the agents. And also we might have the native or third-party AI agents. If they provide their interface to the agents, we can also leverage that. Okay. Also, we will have the native API provided by the application itself, and we will try to manage or translating this API as a plugin of the app agents, and the app agent will just call that to complete different tasks. And also, if the large language model knows how to generate this kind of API, we can just try to use different like code generation framework to generate this API to do the more freestyle work on this application. And the most important skill here is the UI control, and that include the mouse or the keyboards, and also other like any control that can interact on the application. And here we will have three different tools to detect or automate the UI control, including the UI automation that's provided by the Microsoft. And so we have the more general one, the Win32 APIs. Also, and if both of these cannot detect the required API, you will try to leverage the OCR detection or the segmentation detector to try to detect this UI in a visual way. So as I mentioned previously, the host agent it will take the manager role of different app agents. So for the user side, you will provide a natural language interface to interact with the users. And from the app agent side, you will just orchestrate and plan for different task completion, especially for the cross-app task completion that needs multiple apps to interact. And also you manage the app agents for like creating them, deleting them, or registration of them. And the key feature of the host agent is that it can engage from the users and managing the app agents, as well as the task, and you provide a communication channel for both the Windows users and the app agents. So from the user engagement parts, so the host agent will first after you receive a request, you will first do the intention analysis. That will just try to understand what exactly the user is asking to do, and you try to understanding that by translating this request into different executable subtasks that will be done by different app agents. And also, you try to interact with the users if the agents will think anything was missing. They will just ask the user for the clarification, suggestion, or confirmation. And also you will manage a long-term memory this memory will just record the user's experience, their preference, and the app agent's activity. And this is to achieve the better personalization. Okay, so for the app agents management parts, and the host agent will also responsible for like creating these app agents. Once the task was decomposed in different subtasks, and you just create the required app agent for a specific subtask, and also you will just after we create this app agent, you try to maintain a registry for all app agents to understand their function and what it can do and any like user's preference on this app, and you have the and also you call any detailed function of this app agent so that you know how to which app agent you should call. Okay, here I'm showing the details on how to create the app agents. So you can see that the app agent is actually the application plus different like skill and different resources for the application comprehension. So once the host agent receives a request to create these app agents, we will try to uh, equip all of these resources on this application to make these app agents. So this will include some share skills like the UI automation, some share guidance, and some share demonstration library. And we also have some app-specific skills, including the API of the app, some copilots of the app, and different SDK. And also we will have the application-specific help documents, which is in a textual file. And also we will have the demonstration library that was specific for this application. And now we are developing some SDK for the app developers so that they can provide this resources more easily and in a more scalable way. And for the task management part, so the host agent will try to understand the entire task and do the planning, and also you will try to schedule different subtasks in the required order, and also after this subtask was passed to the app agents and during their runtime, you try to supervise their task completions and try to coordinate different app agents to complete the required task. And in the communication side, so the host agent will try to exchange the message from different app agents. So it might just bring the useful information from one app agent to another to just to complete the task, such as when you're dropping emails, you might need some information from the previous application, such as the Word, and you try to exchange this message between these two applications. And also you maintain a blackboard. So this blackboard is visible for all of these agents. So the host agent will just record required information on this blackboard so that just make sure that every agent is able to see this, and they will not forget any important information. Okay, so for the last part is I'm gonna introduce a bit about the large action model that we are developing. So the large action model here actually is it's just a variant of the large language model, and the difference is that instead of it outputs the natural language such as the planning, it will also output the action sequence. So so the LAM is a foundation model that you can predict both the next actions or the next planning for the agents, and it is optimized for the task completion in different agent OS using different resources, and also it have the enhanced skill of the tool using such as the mapping the plan into the function calls and using different of API to just complete the task. So the reason that we need a large action model is that we can have a much low cost and low latency if you have a smaller model of the large action model. So also if you can host this large action model in the personal in their local desktop, it can have better privacy because the user do not have to upload their data online to the model server. Also, it is optimized for the domain-oriented task completion because we will have our data to fine-tune the smaller model, and it's much lightweight and easier to update. If you have some update data available to which so we can use this data to retrain this large language model. So at the first stage, we are collecting different trajectory data to train our large language model. And the first part, we are trying to input the task of the user request, and the output the LAM will just output the solution of this task in a natural language way. So here we are trying to collect the expert trajectory from different sources, including the help dog of the Windows M365 app. And also we are collecting the information from a WikiHow, the bin search, and then we use the involved trajectory to do some data augmentation, and this data they are available for our training, and also we are hiring some human label to label our data, and this is the ongoing work. Another things I just mentioned is that we are trying to use the agent to self-explore on the sandbox, and this will just generate a lot of the runtime trajectory that was more reliable, and we are working on this. Okay, here I'm showing you the latest results that's on our large language model, but this is just for the plan generation. So here the large language model, the base model we use is the Mistral 7B. You can see that before the training, there was our original. The successful rate of our the testing set is 0, which means that you cannot output the required formats, or it cannot complete any task. But after retraining with our data, with our WikiHow and help data, you can see the accuracy just improves significantly. It's very close to a GPT-4. But the good thing is that the average inference time for the GPT-4 is more than 30 seconds. But for our large language model, it's less than 1 second, which is a significant reduction of the runtime inference. And this will after we obtain this model, I think this really make the AI agent OS really workable for our daily life, because if you use the GPT-4, we cannot tolerate this high latency. But just note that here we just use the large language model to generate the planning. But now we are also collecting some action sequence to enhance the large language model. So after we have this action model data available, and this will just enable large the LAM to execute that task on our personal laptop. Okay, so I think this is the end of our sharing. And lastly, I'm showing you some reference of our work. And here we have the code base of our UFO. This is attracting a lot of attention. And also we have a technical report of the agents. You can find this on the archive, and also you might also find some media that's reporting our work. Someone is calling our work is the future of the AI PC, and you can see this YouTuber is testing our framework, and I think he really likes it. Yeah, I think that is the end of the sharing, and I'm happy to take any questions.
Very cool. Well, thank you, Chaoyun, for that. It's actually very fascinating to see what's even possible with with UFO, with the system that you've built, and also even just these models that you're using or even training. So very fascinating, very, very cool to see. One question that I have is, like, how is the agent, or how is your system able to disambiguate the similar learnings that are stored in its library, especially, let's say, when the content is updating or refreshing, and it needs to kind of it's going to have, let's say, multiple examples of the same task. Is that something that a user has to kind of figure out or to refresh, or like how does the agent handle this scenario or this setting?
Oh, okay. So I think The first thing is that we are trying to use some system to identify the version of the application that the user are using. Then when the agent is doing the retrieval, you try to retrieve the specific the help documents or other resources from that version of the software. I think that will just reduce some ambiguity of this help doc or other resources. Other thing I think the agent is trying to do is this: that you try to you analyze the you analyze the state of the application. So if one help doc saying that it's gonna clicking some control that doesn't exist on the current state of the application, you try to do a different way, maybe use a different help doc. That's how the agent try to manage this.
Very cool. And I guess one question to follow up there is when there are multiple apps to even accomplish the same task, right?
Mhm.
Like you kind of gave an example of like, oh, remind me to exercise, right?
Yeah.
Yes, there's like the to-do app from Windows, but there's also you could just open like a notepad or you could just go to the web, right? And go to your calendar, right? Your Outlook and create a reminder there. So when there are scenarios or situations when you can accomplish the end result, which is what, like set a reminder, can it be configured to prioritize like one set of applications over another? Or if it's not configured that way, how does it actually choose?
Yeah, so I think it's a good question. So the host agent will have a function of the intention analysis. So basically, if the agent is unsure about maybe the next action or next application, you will just interact with the user to asking, hey, which there are several apps can do your task. Which one do you prefer? And the user might just select the to-do app, and then we'll save this into the long-term memory of the agents. And so for the next time, you just remember that you just go straight to the to-do app. Yeah, that's one way to manage this.
One like interesting thing that you even showed is that the agent could even leverage other co-pilots or other agents that are part of existing applications. Have you found a scenario where they actually do that? Like where, I don't know, if you're using Office and then or Excel and you want to use the Copilot button there or the
Yeah.
Copilot tab, like where have they actually used it and why?
Yeah, you can see this
Almost
video.
instant
So
help
here is
generating
asking the PPT to generate like a slides from the Word documents, right? And now it's using the Copilot to select those require like work document to generate these slides.
So the thing
Yeah.
is, since the Copilot is a separate system, right? It's a separate, let's even call it like an agent system,
Mhm.
right? How and UFO or the AIOS is its own separate system. Like, how do you imagine this? More, I guess, philosophical. Like, how do you imagine this world where you have multiple agents that are implemented independently, and you're calling on one, and you have to kind of observe. You don't know, the agent doesn't know how it's implemented, so it can't maybe like, I don't know, use it the right way or prompt it the right way. Like, how do you imagine this kind of interaction being happening?
I think this is a good question. So when we do this demo, we actually have to tell the agents what the copilots can do. So I think for the future, I think it's kind of a kind of a thing. We need to do some customization from different like an application to understand their functions, whether they have the copilots or agent or not. And if they have, we will have to tell the agents that what exactly this copilot can do. And we haven't do this now, but to imagine this, we will have a config file to know what is the main function of the these copilots. we inject this to the application into the prompt of the different app agents, and the agent will just know how to when and how to leverage this in-app copilot to do the shortcut of this task. That's how we think about this. Yeah.
Yeah, it's definitely fascinating. It does require the human in the loop in some sense to provide the user manual for how to interact with the copilot. But I think at some point in the future, yeah, these agents may be able to prompt other agents to be like, hey, what can you do? Tell me what you can do. I'm going to store that in my memory, and then use you when I see fit, or when it makes sense to. So
Yeah, I agree. Yeah.
well, this is awesome, Chaoyun. Thank you for dropping by the Pals of Autonomous Agents to present this work. Look forward to more work from your team.
Okay. Thank you, Alex.